Hey everyone, it's Trent here, and this is the first video I hope of many that I can start to dive into some topics that I am really interested in and have a huge passion for, specifically concerning nutrition, at least to start off with. What we have here today is going to be a quality versus quantity conversation, and I think it's a good foundational conversation to have, not only in terms of nutrition, but it also allows me to mess around with some of the video editing and the formatting of how I want to do this. In terms of what we're going to do, I have a PowerPoint that I made myself, and I did utilize AI. I think it's important to mention that, not to make anything for me, but to help condense some of the points I wanted to talk about, find some of the sources that I went and read and we'll look at. And I use it like I believe someone uses a calculator. So don't just do this for me, but make the process more efficient so that way I can do things like that and they don't take away from too much of my time. As far as myself, I am in the healthcare field in terms of being educated right now. I hope to one day be in primary care, and it is upsetting me that a lot of the times I'm not taught about topics like this and other things that we will really get into that I want to touch on. But I hope this is going to be a fun little journey for all of us, and I think this is the perfect segue to start in terms of nutrition. So, quality versus quantity. Let's get into it. I want to start off with some hypothetical questions. If two diets have the same calories, are they equal, right? So our first diet is 2,000 calories total, and it consists of a lot of protein shakes, protein bars, fast digesting carb sources. So just think a bunch of white rice, a bunch of just sugar, right? You can be like a candy bar, even though it fits the macros. And I'm going to the extreme just for example, but 0 calorie substitutes, etc. So a bunch of diet soda. Just, I think that's the easy example. It's very focused on calories and macros. And diet 2 is the same amount of calories at 2,000, but it consists more so of lean protein sources from like animals, healthy fats, we can talk about that later, plant-derived carbohydrates, so just think fruits and vegetables as a majority. And it's very focused on the composition of meals in terms of their quality, right? So there's the quality, rearing its head, compared to just pure numbers, right? So, what makes one better than the other, and would weight gain or loss or even maintenance be the same for each? And what makes each unique? Okay, so the quantity model. Now, I think this is important to start off with because usually this is the segue that people find themselves in terms of nutrition, right? I mean, this is where I found myself as a late teenager trying to get into bodybuilding and fitness. It was all about calories, macros, and as long as I hit those and maintained a lean state, I thought it was healthy, thought it was good, and it gets a little bit more nuanced than that. But starting with the quantity model, weight change is fundamentally driven by energy balance. I mean, this is true. We're not arguing against the first law of thermodynamics, right? Energy can't be created or destroyed, only changed, right? Only converted. So this is the most reliable model in controlled settings and is often quoted as calories in versus calories out, right? You'll hear that 100 times, especially on like online forums, like this is all that matters, TikTok, so on and so forth. The body understands intrinsically that it must either be provided with energy, and if there's not enough energy, then it must take it from its storage. An easy way to think of this energy is in the form of ATP, which can be produced by many different processes, reactions, or sources. So I like to think of this as we intake food, and there's a plethora of things that this, let's just say one carb. In terms of, glucose, it'll go to pyruvate, Krebs, electron transport chain. It's basically, we're just converting this food into a potential energy source into ATP. I think that's a pretty good summarization. And, you get into education, higher level, they'll teach this over and over and over again. So I don't have to get into that for this video. But that's a good way to think about it. And it runs body processes, like everything. So in terms of raw numbers, then it must make sense that if someone either eats less or burns more, then they must lose weight from their own storage, or vice versa to gain weight. If we look to the left here, we have total daily energy expenditure, so TDEE, right? So this is how much you're burning. And these are the big impacting factors. You have your basal metabolic rate, so BMR, or RMR, resting metabolic rate, somewhat interchangeable. I think BMR includes a little bit more. But BMR is basically calories burned if I wanted to sit in my bed, scroll on TikTok, and breathe, right? Now, although that doesn't sound like a lot, this is the majority of how much you burn, right? So that's something that struck me as, holy crap, I'm just thinking about this wrong. when I first came into this, because physical activity, although it's second, so calories burned during exercise, it does not hold a candle to the BMR. Now, if you're like Michael Phelps, okay, we're doing a bunch of exercise to the point where it starts to really make a huge chunk out of how much we burn. But for the majority of what we're going to be talking about, if it happens 51% of the time, it happens most of the time. And I think that's important, right? We have to generalize things. So can you find an outlier, someone who exercises a lot more than they might burn from BMR? Yeah, that's an outlier. So that we can't really apply typical advice to outliers. And we'll get into that more. Number 3, we have NEAT. So calories burned during non-exercise activities like walking or gardening, or even me moving my hands here like this. If you like do your leg shaking in class or wherever, like that up and down thing with your foot, like all of that's considered NEAT, right? And then we have the thermic effect of food. So basically, if I eat, how much of that, or how many calories do I burn to utilize that energy, right? And you'll usually hear like, oh, you burn more calories eating protein, which is true. You can get into like, oh, because you have to process the nitrogen group and the amino acid chains, so on and so forth. But yes, you burn more eating protein, but still nothing holds a candle to the BMR, and that's a really important thing. And what I'm going to do is open this article so we can get a little bit more of a look into something that covers this topic. All right, so here we have an article from the NIH. This is like the biggest go-to research article, paper, publication. We'll get into research a little bit more in terms of like looking at, okay, the criteria of evidence, so on and so forth. But this is it. I don't know if I have to give credit, but here credit to the authors. I mean, it's all here to be easily visible to see. So continuing on, what we have in terms of abstract is the weight changes are accompanied by imbalances between calorie intake and expenditure. And you can go ahead, pause, read, find if you really want to get into it. But I want to kind of hit the ground running in terms of just looking at specific things. So that way it's not boring. Like, look, if I really wanted to go through this, I could. But we're going to continue down here. So it talks about things that we spoke on before, the thermic effect of food, the REE, or the BMR, like I said, kind of equivalent, physical activity, influence of exercise on energy expenditure, and then while often considered a first-line treatment option for obesity, basically large amounts of exercise don't really do as much as we wish it would because it doesn't hold as much of a say-so in terms of how much you're burning, unless, once again, you're an outlier. So this is really why I wanted to pause. Influence of energy intake and energy expenditure. So reductions in energy intake lead to decreased energy expenditure to a degree that is often greater than expected based on changes in body composition or the thermic effect of food. Experimental quantification of metabolic adaptation depends on calculating the residual difference between measured and expected values of energy expenditure. However, the expected energy expenditure is typically calculated based on observed body fat and fat-free mass changes and typically ignores factors like organ sizes or altered fluxes through energy required metabolic pathways. So, nerd talk. The best way I can summarize this is, hey, the thermodynamic effects of food are a law, and it is important, and it makes mathematical clear sense. Nobody's arguing against that, right? But what we're saying is when we apply it to individuals, although it makes mathematical sense, there are other interplaying factors, right? Things that can start to alter the satiety, things that alter the way that you break down certain macronutrients, and things that certain macronutrients do to the body's physiology. So this is really the big thing that when I read before, I wanted to touch on right here. Influence of dietary macronutrients on energy balance and body comp, because this is the bridge between quality and quantity that I think is important. So the energy released during carbohydrate, fat, and protein oxidation within the body can be equated to the energy derived from their combustion in a bomb calorimeter. Basically like looking at, okay, a calorie, how much energy do we get out of it, change the degree of water, kind of thing, right? And so there's different ways to measure both calories, right, what they are in terms of energy, as well as how much you burn in a certain environment, so on and so forth, with suitable corrections for the differing thermodynamic constraints and the end products of the reactions. So, in other words, a calorie is a calorie when macronutrients are oxidized either in the bomb calorimeter through combustion or via the intricate biochemical pathways of oxidative phosphorylation, what I was talking about in terms of like we take this substance and we get it down to these electrons, electron transport chains, so on and so forth, inside cells. So this is important. Continuing. However, the thermodynamic arguments alone do not necessarily imply that a calorie is a calorie when it comes to the effects of diet composition on weight change or composition. Isocaloric diets differing in macronutrient composition may result in preferential partitioning of energy storage towards body fat and away from body protein. Such energy partitioning differences over the long term will alter the proportions of body fat and fat-free mass and thereby influence energy expenditure. Protein in particular is known to positively influence fat-free mass during weight loss. So this is important. Yes, and I'll say this over and over and over again because you'll see that the overall theme is a middle ground. Thermodynamics make sense, and they're set in reality, and they're set in law. But there are nuances when it comes to the quality and the composition of food. And that's where we have to look at the quality argument. So, like I said, you can go ahead and read through all this if you want. That's really what I wanted to get out of here. And we'll continue to the next point. So that way this video isn't 2 hours long. So, where calories alone can benefit or fall short. Calories can provide a strong framework of understanding the large role nutrition can play in terms of body composition, but they fail alone to provide a link to the framework of understanding physiology and interpersonal variability concerning food. Another way to word this is counting calories can and will work for many, especially with weight loss, gain, maintenance goals, but the calories alone are only a piece of the puzzle for some. Although weight loss will thermodynamically occur if calorie input is less than output, it does not mean that the calories alone are sufficient to fully grasp the large degree of mechanisms at play in terms of weight loss, so on and so forth, right? And this is the bridge to food quality. So, what is food quality? The NOVA food classification here on the left is something that we're going to talk about, but I think it's important when we talk about food quality to understand that it incorporates a lot of different things. A simplification of it is nutrient density, so things like vitamins, minerals, fiber. It's the degree of food processing, like that NOVA food classification, and it's the physiological responses to food. All of these fall under quality, right? So if we look at here, and you can go ahead and look at the little fine print, but NOVA food classification system is something I think is very important to start to grasp because we're not really taught about ultra processed foods in terms of understanding what are they actually. We know like, okay, if I go and get like McDonald's, it's probably ultra processed food, but what is it actually? So I like this. Unprocessed or minimally processed foods, things like you see a chicken drumstick, a slab of steak, an apple, and that's important. So things like apple, right? Processed culinary ingredients. We have things like sugar, butter, apple butter. Processed foods. Now we have things more so like looking at applesauce. And then ultra processed foods. Something like McDonald's apple pie, right? I think this is, and I'll use the apple butter, applesauce, apple pie example because this is the framework that we can really start to look at food rather than just calories, because you could have 100 calories of something in each one of these categories, but each one of these categories is going to produce a different physiological response depending upon what it actually is. And that is the take-home message in terms of this. So I'm going to open up this article and we can go ahead and speak on this a little bit more. Okay, so what I have here is an article pulled up from Cambridge University. Once again, all the credit should be here on the screen. And this is getting a little bit more into depth in that NOVA food classification system because I think it's really important, at least where we are now in the United States, there's no like classification labeling system like, hey, this is an ultra processed food. Now there's some people that are pushing for that, but like I said, right now there's nothing at play. So it's really important to be able to do this and not have it be such a stressful thing, right? So if we're going down here, defining ultra processed foods, almost all foods are processed to some extent, right? Kind of like even butter is considered processed, but if only by preservation. And it is therefore unhelpful to criticize foods as being processed, right? That's an outdated thing. If something's processed, it really doesn't hold much weight now. A number of food classifications have been devised to pay special attention to the type of processing. Systematic review, we'll get into what that means a little bit later here. NOVA is the most specific, coherent, clear, comprehensive, and workable in terms of classifications. So, read a little bit more if you want. Here's ultra processed. So, ultra processed foods are formulations of ingredients, mostly of exclusive industrial use that result from a series of industrial processes, hence ultra processed. Processing enables the manufacture of ultra-processed foods to involve several steps and different industries, right? So a lot of the times, like if you've ever seen that nasty like hot dog video where they get like the sludge and they put it together in a factory. I mean, there's factories made for almost everything in the middle of the grocery store, and there's factories for everything, right? But I mean, we're really talking about a bunch of different industries, a bunch of different processes, and it depends on what the substance is. But a lot of times these substances are often obtained from a few high yield plant foods, these cheap corn, wheat, soya, cane or beet. We can talk about the impact of these cheap processed carbs on your mitochondria and metabolic health. Actually, there is a slide on that a little bit later. But we puree, grind animal carcasses, intensive livestock farming, and a lot of these substances are then submitted to hydrolysis, hydrogenation, other chemical modifications. But this is the big thing here: sugar, oils, fats, and salt used to make processed foods are often ingredients of ultra processed foods, generally in combination. And I'm going to pause here, and this is the whole reason why I added this. We as humans have been adapted to seek out large sources of sugars, oils, fats, and salts because when we found them in the past, we most likely survived because it was that rare, right? It was like the best time of the year if we found a big old honey pot or a bush of berries or, something along those lines because it was so hard to find and it gave us efficient energy. So our brains are hardwired to seek these out. And that's why these these industries and big food and all these companies, right? They know this, and they have put billions of research into developing these items that are almost incomprehensible, right? It's just the perfect percentage for the perfect dopamine release. Not too much, not too little. If it's too much, it overstimulates us. We can't handle it. We have the colors in cereals that we know kids gravitate towards. We have a specific amount of sugar we know is going to elicit the response that we want to have to come back, but not give us the satiety cues. And it's just so on and so forth. And you can even get into like the history of, okay, we really started to incorporate them beginning of the 1900s. World War II extrapolated it even more because the soldiers in World War II needed something quick and efficient. And then they came back home and they were seeking it after. And then big food was like, we can apply that to everywhere. It's a big old rabbit hole. But the big takeaway home point for here is understand that these things are made to keep you addicted, and they're made to continuously have you buy them over and over and over again and to seek them out because, like I said before, we seek these items out whether we know it or not. Additives that prolong the duration, protect original properties, prevents proliferation of microorganisms may also be used. So this is where you see a bunch of those random chemicals that you see and you're like, oh my gosh, I don't even know what this is, on the laundry list of items. Things like that are also considered ultra processed foods. So if you were to go to a grocery store, look at a label and, number one, not recognize things, or I've heard someone say like your ancestors wouldn't recognize a lot of these ingredients, that's a good cue, it's ultra processed. Or if you were to go to the grocery store, look at the ingredients and say, I could never replicate this at home. Go look at a box of Kellogg's Frosted Flakes. Look at those ingredients and go make it at home. It's like, I can't. Like, that's a good sign that the food is ultra processed, and it's a good sign that it has things to keep you addicted, right? So I thought this was a great little, like I said, read this more in depth if you want. But identifying ultra processed foods is just going to be vital if you care about the quality of food. Because I was eating ultra processed foods and I'm just, an N of one. So N equals one it's like one subject. So it's hard to apply that to a broad range of people, if I was going to do a study. But as an antidote, I never cared about if something was ultra processed or not. What I cared about is this super ultra processed protein bar with fake sugars, additives, fats, hydrogenated seed oils, everything. Does this hit 20 grams of protein for 200 calories, right? That whatever ratio that people just love to bring up. Yes, it did. But what was it doing to me in terms of physiology? So that's a good way to go on to the next point. So let's head back to the PowerPoint. All right, ultra processed foods. When consumed, these foods, via their vast array of cheap additive substances, like we talked about, right? The sugars, salts, fats, lead people to consume more calories even when macros are matched with other diets. And this is a combination. Like, although we have someone who eats, 2,000 calories of all these ultra processed foods, they're more than likely going to have more than 2,000 calories because they can't adhere to their satiety cues. Now, is there an outlier of someone who can plug everything into a calculator and stop themselves from eating more and then still lose weight or still gain weight, whatever the goal is? Yes. But that still doesn't negate the fact that you're changing your body's physiology, right, in terms of metabolic health. So from faster eating rates to lower satiety signals, ultra-processed foods are designed to keep the consumer eating more whilst feeling less, leading to increased energy intake independent of hunger perception for the most part. Because a lot of people aren't as crazy as bodybuilders or fitness enthusiasts that sit there and track every calorie. They do, sometimes they take a picture or they plug it into an app, and it's more so based on how they feel they want to eat. And a lot of people lean into those hunger cues rather than pure objective, plug the numbers in, plug the numbers in, plug the numbers in, right? So really altering that hunger perception is a huge thing that ultra processed foods are designed to do. Going into macronutrient quality, so these are some of the things that macronutrients can impact in terms of the difference of proteins. So protein contains the highest thermic effect of food, as well as being highly satiating, and you can really get into the difference of, like I said. So macronutrient quality, so these are just some potential future topics. Protein contains the highest thermic effect of food, 20 to 30%, like we kind of talked about before, as well as being highly satiating, but not all protein is considered equal. And I'm just talking about if it's complete versus incomplete amino acids, right? You'll hear that, like collagen is an incomplete amino acid for muscle building. So you can have 20 grams of collagen, but you're not going to build that much muscle with it because it's insufficient in certain amino acids. So that's something. But also, hey, if we look at just if I have 100 grams of whey protein every single day versus I get 100 grams of protein from animal sources, as an example, what are the animal sources going to do in addition to providing just the protein number, right? Because whey protein is a very very high bioavailable protein source, but you're missing a lot of the nuance with the stuff that should come or usually did come from animal protein sources. So fiber also increases satiety via gut fermentation in short chain fatty acid products. This has to be a whole new topic, a whole new video, because the microbiome, I like to think of it like, when you hear, oh, we've only explored this small percentage of the ocean, it's like the same with the microbiome. Like, we barely touch the thing, but we know it impacts almost everything, right? And we have so many different like supplements that try to adjust it, so many different foods that try to adjust it, and it's just, that's going to take some time, and I would really need to dive into what we know right now. I mean, I have a basic understanding of it, but to really put it into a video, I can't do it justice right now in this content that we're doing, quality versus quantity. So just know that that can be coming up. And what I think is the biggest thing in terms of a really good example of quality, fat type and consumption influences oxidation status of the body, LDL-C particles, and even ApoB levels as well. So seed oils versus animal fats, I think, is a great example of this. This is a topic that is all about quality of food and the impact that it has on things like the LDL-C, the ApoB. These are like cholesterol markers. ApoB is on things like LDL-C, VLDL. It's like ApoB is a good marker of overall cholesterol health. And I think as we go on, that's going to be the new gold standard of cholesterol markers. But the fat type. So if we eat a certain fat, what's it going to do to my oxidation status? Which everyone always says, oh, like I ate this food and I became inflamed, right? That's another thing. So really a lot of what they're talking about is like I ate this and induced oxidation and I had an inflammation response. But that in and of itself, when I get to that video, which I want to do soon, that's going to be an extensive video. And I want to do that topic justice as well. So these are just some potential little future topics I thought I'd throw in there. Okay, now this is what I'd say is the meat and potatoes, I guess pun intended, of the food quality conversation. Really what I would like for someone to think in terms of when I care about food quality for my own sake, and I'm saying like if someone does, really what they're saying is I want to have pristine metabolic health. And metabolic health, I think a good summarization is how efficiently is my body utilizing nutrients, how efficient are my mitochondria, and how efficient are my bodily systems attuned to the physiology that it's capable of, especially for long-term quality of health. That was super nerdy, but I really do think it's that important, and it encompasses a lot, and that's a good summarization. So in a situation where similar calories or macros are met, the difference between high quality and low quality foods directly influences things like insulin sensitivity, blood glucose control, cholesterol and lipid metabolism, inflammation markers, liver health, hormones, etc. It touches everything. This point is vital because it separates weight outcomes from health outcomes. Oftentimes, a weight outcome goal is the sole measurement of success, but health outcomes can vary. And this is a good example. When we think of someone who, like two different people, both went from 250 pounds to 150 pounds, but they did it completely different routes, kind of like those two diets we talked on in the beginning. they can have different end results. Their physiology can be different, right? Let's look at the last point here. The ability to control internal biology is the center of metabolic health, which is an extension of food quality comparative to just the quantity. And going back to that 250 pound to 150 pound example for those two individuals, if we look to the left here, excess weight in the abdomen is a perfect example. If you ever heard of someone who's like skinny fat, so they're skinny but they have like a lot of fat in the abdomen, a lot of times that is visceral fat. So excess weight in the abdomen is it's a pretty raw measurement of visceral fat in and around the organs. And we know that that fat is so damaging to a multitude of processes. It can induce chronic low-grade inflammation. And when I say inflammation, I don't use that term haphazardly. I mean, it actually induces inflammatory markers, right? Inflammatory markers are signals your body sends out to its immune system to say, hey, I need some help. There's something that shouldn't be here, right? So let's induce cytokines. Let's induce things like interleukin 6. Let's induce things like C-reactive protein, right? Interleukin 6 can induce C-reactive protein, which induces things that can help go back to the area and to clear things out. But if your body has visceral fat, it's constantly producing these signals in and out again itself over and over and over again. And then you have chronic low-grade inflammation, which can then damage different parts of the body, right? So that's just an example of the difference that two different diets can have with the same end result. I mean, they both were 150 pounds, but look at the physiology behind that. So what this is on the left is really the criteria for metabolic syndrome. So to be diagnosed with metabolic syndrome, and this is from Cleveland Clinic, I think you need like three out of five criteria, or maybe it's changed now, but low levels of HDL cholesterol, elevated blood sugar levels, high blood pressure, the weight in the abdomen like we're talking about. So that'll be it's like a belly measurement, and hypertriglyceridemia. So all of these things are independent markers of that summary of metabolic health like I was talking about. How efficiently are you intaking and utilizing nutrients, and how efficient is that going to relate to your overall quality of life? Because when any of these things are kind of off balance, they work in and around themselves, also independently. But metabolic health is the overall goal when people look at food quality. Really, when people care about food quality, and you see all these things online and what doctors talk about in terms of food quality and health professionals, we need to attune you to a good metabolic health, because if any of these are off, you now have risk factors for a plethora of diseases, right? You can just start naming all the things that everyone's scared of, like the cancer, the diabetes, the heart disease, the stroke, like all of this, right? So that's why this is so important, and I think this is the center of the quality conversation. And this brings us to the second major point I want to drive home, and I'll have to bring this up again and again for future videos, but why and where food science conflicts. So studies range from observational models trying to show long-term associations, reverse controlled trials showcasing direct interventions, often for a short period of time in regards to nutrition, as well as mechanistic studies that can display pathways but not true population behavior. A bunch of words. Basically, it's saying we have a bunch of different studies from a bunch of different angles trying to show a bunch of different things, and they're consistently conflicting, right? So I want to kind of help navigate the field of research topic to topic, and you almost have to do it from topic to topic because it's just so nuanced. So simply put, the criteria of evidence concerning nutrition has trouble allowing the level of control needed to make direct causation claims, and oftentimes is muddled with different studies trying to prove different points. So it's really unethical to lock the thousands of people that we need into a very specific environment, force them to eat a very specific diet for a very long amount of time to get direct causational results. I mean, there's some studies in the mid 1900s to maybe 1980s, it's like that, tried to do this in certain environments, but it's so hard to do that with nutrition. And that's why research is hard, because you almost have to look at things like lower criteria of evidence. So looking to the left here, this is an example of like the research pyramid. So things at the top tend to hold more weight in terms of what is true versus the bottom. So like at the bottom, we have like practitioner wisdom and expert opinion, right? So on and so forth says. And then a little bit above that, we have qualitative and quantitative case studies. So single course, institution, single method use. So like a case study can be like we're looking at one person and we have an effect of a certain thing and what happened over the course of a certain amount of time. Like that holds some weight, but not as much as something above it. qualitative and quantitative cohort studies. So now we have multiple courses, institutions, mixed methods, broadly applicable. So now we can look at like things like double blind trials, right? Like all of these buzzwords you'll hear, but the higher it is on the pyramid, and here we have at the top meta-analysis and systematic reviews, the higher the degree of authenticity and the closer to the truth that people take it as, right? So like a systematic review, I like to think of it as it's a study on studies. So we're going to take a bunch of different studies, try to extrapolate out all of the information that they did, and then we're going to do a study on all of it and what's the overall consensus for the majority of the studies. Basically, what's best on average or what happened on average. But sometimes people get too caught up in that it's a systematic review that they fail to go down a level and look at each review. Because if each review had some little things that were wrong with it, then the systematic review overall is going to be misinterpreted. So that's why it's important to look at both the little amounts of research, one by one, if you can, and then the overall result. So each individual topic, therefore, must be broken down with precise detail, and then the weight of each study can be measured in totality. And that is what I want to do topic to topic, right? Now, some topics are a little bit more controversial than others, especially the one I really want to touch on is the heart disease, right? The number one killer of humans worldwide. I want to dive into that topic, especially concerning nutrition. But to talk about nutrition and heart disease, you have to talk about the criteria of evidence. You have to talk about heart disease. You have to talk about cholesterol. You have to talk about all these things. I'll get into that. Trust me, that's the one I really want to do. That'll be a long video. But this is kind of a dipping your toe in the water into research, into understanding the criteria if you've never looked at it before, and how to come out of this with a little bit of a different lens, that not all research is the same. And that's why you can have someone who has a study shows A, a study shows B, they're conflicting. How can you have two studies that show different things, right? We'll get into that. And towards the tail end, we're getting close to the end here. The integrated model, so back to quality versus quantity, right? An integrated model seems appropriate then to incorporate both sides. With an understanding that calories do determine body weight outcomes, food quality modifiers can simultaneously be added in terms of hunger regulation, lipid metabolism, adherence, long-term energy intake, and a plethora of other metabolic impactors as well. Incorporating strengths from both models can allow an individual not to only alter their current weight, but also their current metabolic status, which in turn can drastically improve their quality of life. So it's so important, and this is like a lot of life. A lot of the times, the true answer lies somewhere in the middle. So if you find yourself too far on one end versus the other, in this case, it's going to like just numbers is all that matters. It doesn't care, or I don't care if you have 2,000 calories of Snickers, or you're going to lose weight if you only needed 2,500 to maintain. Or it's like, hey, that is horrible. Calories don't matter. It's all about the quality, and then things will happen after that. If you find yourself backed into either corner, you're missing on the benefits of the others. And this is a drive home point. You need to find a balance between these, right? And this is an easy topic to do so, but when we touch on harder topics, it's going to be a lot more difficult because people are they like to hear what they believe is true. So yeah, this one is like, all right, everyone, it's quality and quantity, but we get into some hard topics and it's going to be a lot more difficult to find that middle ground. And that's why I chose this topic to begin with, because it's easy to do so. But remember this as we go on. So focusing on factors such as not only calories, but what makes these calories up, the protein sources, the fiber or lack of density, processing level, etc. All of these help combine both ideologies, right? So we're going to end here with a Reddit. So let me go ahead and open this up and we'll touch on this. We have here, credit to Reddit. If all that matters in weight loss is a calorie deficit, why should I eat healthy food instead of junk food? So this guy's basically asking the question that we kind of start off right to begin with. And what you'll see here is a lot of like, hey, it's more than just the calories. It's a mix of stuff. So like I said, it's a pretty easy topic to find a good middle ground in. But we scroll down here, and I thought this was funny. You'll find an example of people who tend to go a little bit too far on one side versus the other. So This guy's like, you're using an outdated and myopic method of dieting based on bunk science. The body's not a machine, it's a complex series of interrelated living systems, strive for health and wellness, blah, blah, blah. And this dude comes in and like, no like flack, I'm not like making fun of these people or anything, but this is just an example of like, this guy's like, what a horrible take, what tortured semantics. And this guy is just like that kind of just Reddit cringe language. It's like, the body is not a machine. He's just quoting this guy. Most obesity is due to malnutrition. It's just preposterously fallacious. All right, so here we are. I mean, credit to Reddit. If all that matters in weight loss is just a calorie deficit, why should I eat healthy food instead of eating junk food? So kind of asking the question that we got to the beginning, right? And like I said, there's a lot of comments that showcase it's easy to find that middle ground, right? It's true that eating junk food will allow you to lose weight, but so on and so forth. But I thought it was funny, an example down here, when we see if someone goes too far to one side or the other. So this guy's just talking about dieting. He's like self-control. Sometimes I get on more of my calories. Since I'm doing this, made a point to start a multivitamin. This guy's like, you're using an outdated, myopic, nearsighted method of dieting based on bunk science. The body's not a machine. It's a complex, blah, blah, blah. And then this guy comes in with his like Shakespearean language. I just think there's like no flack to these guys, but it's just funny. It's like, this is just that cringe Reddit language. It's like, what tortured semantics. He's just quoting this guy. He's like, what you're saying is just preposterously fallacious. You're a clown. Like, I was just like, oh my gosh. This guy's like, hey, bro, you're misinterpreting my words and jumping to an ad hominem. Oh my gosh. And then this guy, it's just like, I'm not doing that. I'm not jumping to any ad hominem. What I'm doing is a reverse. It's not logically fallacious at all. What I'm doing is making the typical logical leap because you spout whatever, you're a buffoon. I'm entirely materially different claim, more logically sound claim, a claim that makes no argument about the you spout. And it's just back and forth. And basically what this guy is saying, hey, calories, all that matter. What you're saying about quality is just bull, right? If he has lower calories, he's going to lose weight. And this guy, at least what I took from it was, hey, or at least this guy here, you can get into it a little bit more. It's basically like, look, I'm talking about quality, and if you focus on quality, your body's going to want to, be able to control its own quantity on its own. So, like I said, that's just a funny example to me of if you fall on one side or the other a little bit too much. But keep that in mind. I'm going to keep mentioning this. We will find the middle ground, hopefully, if it makes sense in a lot of these issues. And you can find examples here of people that tend not to do so, even on a little bit easier topic, right? Like, here's another middle ground. You'd be fine from a nutrient standpoint. If you only ate honey buns, you'd be fine from a nutrient standpoint. You shouldn't worry about vitamins or amino acids as long as you're eating some non-extreme blend of human food. Junk food doesn't fill you up. It will make you feel like, yeah, if you only here's an example. Look, and I'm just reading this now for the first time. If you only ate honey buns, you'd be fine from a nutrient standpoint. What nutrient standpoint? I mean, you'll have energy. So yeah, you're not going to like wither and die. But look at what's in a honey bun. Look at the quality. Look at the processed sugars. Look at the way it would impact your physiology. Look at the metabolic syndrome we talked about. So that's someone who I'd say is a little bit on one end, versus the other, right? Junk food doesn't just fill you up. It will make you feel like, So, yeah, funny thing. You can find a million examples of this, but just keep that in mind, right? All right, and to summarize everything, overall, the world of nutrition is constantly evolving, and it can seem very daunting at first. It definitely did for me, and still does, right? I just learned something recently. It was like, there's a difference in saturated fat impact in terms of like LDL, a modification of your body. If a saturated fat is in a globule matrix, like in dairy, versus if it's not, versus like straight meat saturated fat. And I was just like, oh my gosh, another topic I want to learn about. But that's the fun of it. I have fun with that, and I think that it should be fun for you too if you really enjoy nutrition. So there are studies that can be pulled to support almost any claim, and people can find themselves falling within one category versus another, like we just saw. In terms of nutrition quality versus quantity, it seems the best route is to take and understand the importance of the incorporation of both models. Like I've said a million times now, if any model lives in isolation, you miss the benefit of the other. Nutrition does not live in a bubble, but is a direct choice that someone can make with clear impacts on their health. I mean, think about it. If you eat on average 3 meals a day, 365 times a year, it's over 1,000 choices a year you have that directly influences your health. I mean, think of something else that has that much of an impact. So maintaining a healthy weight is desirable, whilst at the same time maintaining a healthy metabolic status is just as important. The ability to be open-minded, educated within the research, and accepting that the world of nutrition is not black and white from person to person is vital, and I hope to explore many other topics, like I briefly mentioned here and there today already, in depth as we continue. So, I hope you enjoyed this. I hope that it was not too boring, because trust me, I've gone through enough long lectures to know that it's just the worst. But I tried to include like research, research, a little fun stuff. Hopefully it gets better from here. I'm looking forward to really digging in on some of those hard topics, but I think that this was the foundation needed to branch off of, both in terms of understanding how the heck I do the editing, whatever, for the videos, as well as the basics of nutrition. So I'm glad you stuck to the end. If you like it, hopefully you stick around for some more, and I will see you guys on the next one. So thank you very much.